my elections. I wrote originally 15, but I noticed the time is not enough, so 12. I focus on the top 12 most important practical questions in relation to organizing the report model. Predictions, and you can join it on the slider. So let's see what the opinion is. And I will, as I said, as soon as we finish, I'll put the raw result on the Telegram channel. OpenGeoHub. You can join the Slido. You have the link in the MetaMask. I put the link, or you can scan the QR code. So I think a bit more than 12 questions. 2 questions just to warm up. And I won't have time to explain all the questions and have all the discussion, but we can continue at the cost. If you use the QR code, it's in the MetaMask, you can see the link. So one of the first questions is technology beginning at the end of jobs for us. And as you know, AI technology today, you can do lots of silly things. You can take 2 phrases and you combine them. It's a bit disturbing, maybe. You can do a lot of silly things. And also, what's getting silly is that people use AI to trick their professor, and then the professor doesn't have time to read what they wrote, then they use AI to compress what they wrote. So they think themselves, it's a bit silly setup, right? And then the second question, I will come with these questions in Slido. So I'll come with this question slide. I just want to go through all the questions to explain that, and then we'll go. So another interesting question is: do we stop with learning how to code? Do we stop because you see these 2 guys says, in the future, you can stop worrying about coding. You should boost your knowledge of physics and math. And the research of the topic, Claude, really amazing. It really can make a Python library, in 10 minutes. And then, what about if we have a student here at university, maybe in academia, student uses 100% ChatGPT, Claude Code, or Gemini to generate the report? Should we send it back to school? Now we have also this GeoFM, GeoAI, and it's really developed rapidly, so you can automate so we call autonomous GIS. It automates the analysis, and as output you get maps and charts, not just the text. You get the text, but with the GeoAI you get as output you get like a leaflet map or something interactive. And there's quite some now companies offering directly GeoAI on top of this Google Earth Intelligence. Even call it sort of Minecraft. Geography is called Minecraft. If you see this video. Then we have also very easy today in Google Earth Instrument can make maps. Everybody can make a map on global data. Next day we have a global map. And so what we have is a flood of mapping projects, especially land cover. So there's so many land cover projects today. For every pixel we estimate there's at least 15 land cover projects. So is that a good thing or bad thing? Are we going to be flooded by amount of products and basically same thing? Then also we have now these space agencies that are competing with these missions. Even inside the European Space Agency, there's multiple solutions for the same thing. And the question is, do we need more missions or we need more field work? What do you think? More missions or field work? Then this GeoML or GeoAI, when we use it, we can generate predictions, but sometimes these predictions have a bias. And it's all dependent on the training points usually. And you kind of do analysis of some data that's prepared by other group, and let's say this data has a bias, but you will be lynched for the output, even though you're not responsible, you didn't create the training data. There's also extrapolation problems. There's also machine learning is very sensitive to blunders. And there's this people overfitting happens to everyone. So this is an extrapolation problem for random forest, classical school example. If you use a linear regression, no problem. If you use random forest, it just remembers the last in the learning has no structure, absolutely no structure, just starts repeating where it stops. So obviously extrapolation from them. People use FreeSum. They just throw the data you can just throw the data on a big file and look for patterns, relationships without any concepts, without understanding anything. So that's also a question, should we do? Then there was this thing with the overfitting, the points which are really clustered. If you don't consider this clustering effect, you might overfit. It happened to me. I published one paper with overfitting. Luckily, we reported that it's overfitting, but we didn't understand why. We just said, look, it seems like it's overfitting. But it was because of spatial clustering. And there were some papers where they actually found out that some previously published papers, other groups, they had so-called quasi-null predictive power actually. So they claim some R squared, but actually it was close to zero. Then also to extrapolate, is extrapolation something we should support or not? If we don't like extrapolation, we could just mask out the pixels to these extrapolation areas in feature space, or because the prediction area is too high, so you could just mask out pixels, and then you don't have a complete map. So then the visibility of data is less. People say, well, where's this missing pixels? What do you do with that? How do you predict future? You know, many of our work actually, we predict future, but how do we validate this prediction? We wait till 2035? It just doesn't sound good, right? So we were looking at this problem of predicting future and extrapolating in future. So we noticed, okay, one way to solve it is to predict the past. If you predict the last 30 years, and then you can cross-check that model, and you say, well, with the model, we understand it. You know, we can predict last 30 years, it's okay, accuracy. That gives you some confidence to predict the future. But otherwise, it's very difficult to validate the future. My colleague, will talk about this. Maybe for some things, it's not easy to predict future, but some things, you know, it's complicated, there's no way to validate what the future will bring. Then also, is it more important that we do reconstruction of Earth observation data, that we make methods and put effort into analyzing data going backwards, or is it okay just to focus on the last 3+ years? Where should we invest more? We at OpenGeoHub, we decided, no mistake, I want to see opinion, but we are more interested in reconstructing, understanding last 50 years. And it is more complex. It's you know, running analysis in recent years is a low-hanging fruit. Trying to reconstruct what happened last 50 years, it's way more challenging. Now we are at 25 years, but we like to move to 50 years. Because many of these changes, you know, they happen in some year, and some changes are very gradual, and you won't see them on a scale of 3 years. So you need really to look on a scale of 10, 20 years, and then you start seeing some land degradation. And you can separate the noise from seasonality from long-term trends. Then also very interesting, there is a one data viewer which is called SLA back, kindly provided by SLA, and this one has a 30 centimeter whole world plus 15 years. So this is the week, this is where we are now. You can go through past the last 15 years, but you can see every tree, you can see the car. It's not a multispectral or hyperspectral, it's just optical images, but it's 30 centimeter. And if somebody cuts a tree, you can see somebody did here, something was dug out, you can see. In lots of images you can see. So should we invest more time into very high resolution or hyperspectral? Where would you invest more? It's very interesting to see. Then today, because we have this open Earth observation data, and we can see these trends, we can for every pixel, we could say your degraded land or you have a negative footprint. And should people pay tax to that? That's very interesting, very interesting question. If you don't manage your land correctly, should you pay tax? So for geotax. I'm very interested to hear what you think of the last question. Now that we have these Google embeddings, are all the problems solved of the geoscience? Could we just use these embeddings and we don't have to worry about whether it's anything or Landsat? We just go any problem we have with Earth observation, we just go use the embeddings. Because apparently the information with 64 embeddings. So that's another question. So these are the 12 questions. So please, let's start with the slide on. Okay, so let's start with okay. So the questions, will come back to that. The questions. Let me see. Let's start this one. Okay. So what is your age group? About 70. What is your profession in one word or in one sentence? Quite some soul scientists. Travel nomad. Okay. How do you rate your knowledge of machine learning? 1 is beginner, 5 is expert. How do you rate your knowledge of spatial statistics? Is statistics the same as machine learning? I think grind rate is just statistical for machine learning. Not many extras. That's very interesting. What is your preferred coding language? Okay, that's very fast. Which coding language you would best like to improve to the black belt level? Nobody's using Mojo. Either from Russian or Sweden. Into which skill would you invest more in the coming 5 to 10 years? Smart physics or coding skills, data science? I hope you see the one on the left is the math and physics, and one on the right is the data science and coding. You can see the text on the bottom? Yes. Is AI technology the beginning of the end of model analyst jobs? One is not at all. 5, yes, soon all will disappear. Oh, that's really interesting. You're all very naive, I have to say. 5, 5. But it's nice to see how naive you are. Incredible. This is this is shocking for me to see. If your student does 100% of their homework using ChatGPT, Cloud Code, Gemini, etc., should they be sent back to school? The one on the right is it's fine, so you wouldn't send them back to school, and the one on the left, yeah, send back to school, total cheating. Oof, very, very divided, very interesting. A flood of global mapping projects. Is it a positive or negative development? Left is negative, right is positive. After this, we finished tonight. I will write a little blog post and put the results. So you can also comment publicly. I agree, it's positive. For the success of the meta monitoring across the globe, do we need more Earth observation missions, or should we do more field work? Right is the field work. Left is more Earth observation missions. And neutral is obviously true. Two more questions. Extrapolate or not to extrapolate? Should we mask out the pixels at an extrapolation space? So on the right is no, extrapolation is fine. On the left is you should mask out the pixels. And the question is then, what do we do with these pixels? Just put the disclaimer.
Yeah. Of course, it's more chill and also the public requires figure less. And that's what I told you. But
How to predict long-term
yeah, we need to be
future?
on top of it.
How to know if model is any good? Practice in reconstruction,
As well, Anna, yeah.
establish a
stable.
monitoring to start validating. In digital Earth twins, this is the only way to go, or something else. Digital twins is you simulate so you don't just do data science, but you want to really understand how system works into detail.
Mm-hmm.
This is something we will discuss also on Thursday a bit, but it will be on stage with people. Should you invest, if you had money, would you invest into reconstruction of the past, or it's okay just to put more money to get better data for today? Oh, very divided. Very interesting. If you have to choose between open access, very high resolution, or hyperspectral but coarse resolution, which should have a priority? On the left is the very high resolution, on the right is the hyperspectral. On the very high resolution, we can see people remove one tree or build a road, and on the right you can see the type of material, but coarse resolution. Also seems to be quite divided. If you put in the middle, then you're neutral.
So it feels more cute.
The geo penalty, geo tax, should people be paying? The people that own the land, should they be paying the tax if they degrade the land, if they decrease soil health? On the right side is yes, it's a positive thing. On the left side, I don't agree. These questions will soon pop up, there will be all of that. 50 years ago, we didn't know this didn't work in the world. It was speculations or stories. Now with the satellite images, you can see how over 10-meter resolution. And you can go, once you can go 50 years back, and you can see at least the land cover. But there's also very high resolution images. Very interesting that most of you agree that there should be a tax, tax. There's the other thing. What if you, for example, we have a project, we map a soil health of a soil using Earth observation data. However, if we do it, the owner of the land uses on the value, so they can sue us. Because if they want to sell the land, and if they lost on soil health or soil quality, or if they degraded land, they lose on the profit. So, and they want to hide that information. They want to make their privacy law. They protect them. The question is, what is more important, the public awareness or the privacy of a citizen? Which one is more important? Also, this is the question we have now in process. We have a next week to discuss this stuff. So very interesting to get your opinion. And it's going to come more and more often. Which one is the more important, the public awareness or the privacy of landowners? Last question, I think. One before the last. Google Earth embeddings, are they solving the problems? We just use on Google Earth embeddings. You don't have to access Sentinel, Landsat, at least for the last, what is it, 8 years or something? So last 8 years, we don't have to use Sentinel-2, Landsat, Sentinel-1. We just use Google Earth embeddings. They are completely consistent, best possible resolution, cloud optimized, ready to go. Very interesting. So most of you live neutral. By the way, I just shared yesterday some group published a new Google Earth embedding product. How's it called? Tessera. Tessera is like Italian. It's Italian word for test. Tessera, no. Greek, okay. But they published another solution. Apparently, it's open source models are publicly available. The Google Earth embedding models are not proprietary. What is the best file format for sharing analysis ready data or decision relevant data? DRD, ARD, or ARD? What do you think is the best solution? We'll come back to this on Thursday also, but just to start checking with you. Are you more the next CDF, GeoTIFF, or GeoZar person? We will split in the groups, the 3 groups. We could try Ultimate Frisbee, the GeoZar versus the GeoTIFF. And let's see that.
I get like 3.
That's it for me. There were some questions I will answer.
Like
the questions on Nethermost. But this is it. This is my very quick slide. Thank you so much. And I will write tonight a little blog post and I'll put it on Differ and I'll share it so you can comment and take discussion there. Otherwise, on Thursday we will continue this discussion and I'll share the real results and on the Telegram and on Nethermost. Thank you so much.